This sounds bad, because it is. China has just unveiled an AI chip architecture being described as up to 1000x more efficient than Nvidia's GPUs. And on paper, it makes traditional GPUs look slow, wasteful, and outdated. What this means is simple, but uncomfortable. The AI world may be preparing to move on from GPUs entirely, and that shift will directly affect pricing, availability, power targets, and the kind of cards Nvidia builds next. If you build PCs, that should get your attention. In this video, we're breaking down what this chip actually is, why Nvidia is taking it seriously, and why this so-called AI GPU killer might end up helping PC builders more than hurting them. Because when AI stops fighting you for GPUs, everything changes. How GPUs took over. Everything. GPUs were never supposed to end up here. For most of their life, graphics cards had a clear, simple job. Push pixels, render games, make things look better and run smoother. That was the deal. You upgraded your GPU to get higher frame rates, better visuals, and a longer life for your build. But quietly in the background, GPUs started getting used for something else entirely. Engineers realized that the same thing that made GPUs great for gaming, their ability to perform massive amounts of parallel math, also made them perfect for training artificial intelligence. Neural networks don't care about textures or ray tracing. They care about repeating the same calculations millions of times. And GPUs turned out to be incredible at that. That discovery changed everything. Almost overnight, GPUs stopped being just gaming hardware and became the backbone of modern AI. Suddenly, the same card you were eyeing for your next build was also being bought by cloud providers, research labs, startups, and governments. Buyers who didn't care about MSRP, power efficiency in a bedroom PC, or whether a card even fit in a normal case. They cared about one thing: raw compute. And once AI entered the picture, gamers were no longer the priority customer. They were competing in the same market as data centers, with effectively unlimited budgets. That's when PC builders started feeling the pain. Prices climbed fast. And not just because of inflation or shortages. GPUs themselves started changing. They got larger, hotter, and more power-hungry because those traits didn't matter in a server rack. A card pulling massive wattage wasn't a problem if it was running in a climate-controlled data center. Overbuilt coolers, enormous dies, and extreme power targets became normal. Not because gamers asked for them, but because AI workloads justified them. Every new generation began to feel less like a gaming upgrade and more like industrial equipment that just happened to run games well enough. And here's the part most people don't fully connect. AI didn't temporarily borrow GPUs, it permanently reshaped them. Once it became clear that AI compute was more profitable than gaming performance, the entire design philosophy shifted. Software ecosystems locked developers in. Hardware roadmaps followed data center demand first. Gaming became a secondary feature, not the core mission. If you've ever looked at a flagship GPU and wondered who it was actually built for, the answer is simple: not primarily you. GPUs didn't get worse at gaming. They just stopped being designed around gamers. And that domination, that total takeover of the GPU by AI, created a massive blind spot. Because when one architecture becomes the default for everything, people stop asking whether it's actually the best tool for the job. And that leads to the real question. If GPUs are so powerful, so dominant, so essential, why did anyone feel the need to replace them at all? That's where things start to get uncomfortable. The dirty secret of GPUs nobody talks about. Here's the uncomfortable truth that almost never gets said out loud. GPUs are incredibly powerful, but they're also incredibly inefficient. At what AI actually needs, they win by brute force, not elegance. A modern GPU throws massive amounts of silicon, power, and memory bandwidth at a problem and overwhelms it. That works, but it's not clean, and it's not cheap. For PC builders, this shows up as massive power draw, extreme heat, oversized coolers, and cards that feel more like space heaters than components. For AI workloads, it shows up as something even worse: wasted time and wasted energy moving data around instead of actually computing. The real bottleneck isn't compute, it's memory. GPUs spend an enormous amount of time shuffling data back and forth between memory and compute units. Every time data has to move, you lose efficiency, you burn power, you introduce latency, and the more complex AI models get, the worse that problem becomes. So, what did the industry do? It didn't fix the architecture, it just scaled it. More of RAM, wider buses, more power, bigger dies, bigger cards, bigger bills, and this is where the illusion starts to crack. GPUs look fast because they are fast at general-purpose parallel work. But AI isn't general-purpose anymore. Training and inference are highly specific workloads with predictable patterns. Using a GPU for modern AI is like using a high-end gaming PC to run a single mobile app. It works, but most of the system is sitting idle or doing unnecessary work. That inefficiency didn't matter when GPUs were the only viable option. But once AI became the dominant workload, those inefficiencies became impossible to ignore. This is also why power draw has spiraled out of control. AI doesn't care if a card pulls 400 watts or 700 watts as long as it finishes faster. Data centers can brute force cooling and electricity in ways PC builders simply can't. So GPUs kept growing in that direction, optimized for environments you don't live in, solving problems you're not trying to solve. And the more Nvidia leaned into AI, the more acceptable that trade-off became. To be clear, this isn't a knock on engineering. GPUs are doing exactly what they were designed to do. The problem is that the world changed around them. AI stopped being experimental and started becoming industrial. And once that happened, the question shifted from how powerful can we make GPUs to something far more dangerous for Nvidia's dominance. What if GPUs were never the right tool for this phase of AI in the first place? Because the moment someone asks that question seriously, the moment someone designs a chip around AI itself instead of bending GPUs to fit, the entire foundation starts to shake. And that's exactly what just happened. China's AI chip monster. Why this isn't just another GPU. What China built here isn't a faster GPU. And that distinction matters more than the performance numbers themselves. This chip doesn't try to beat GPUs at their own game. It ignores the game entirely. Instead of taking a general-purpose processor and forcing it to behave like an AI engine, this architecture is built from the ground up around how modern AI models actually work. That single design choice is what makes the gap look so extreme. The biggest change is where computation happens. In a traditional GPU setup, data is constantly moving, from memory to compute cores and back again. That movement is expensive. It burns power, it adds latency, and at scale, it becomes the dominant cost. This new architecture collapses that distance. Memory and compute live together, tightly integrated, so data barely moves at all. The chip spends less time shuffling information and more time actually doing useful work. That may sound like a small change, but it completely rewrites the efficiency equation. When people throw around the 1000x faster number, they're not talking about clock speeds or raw teraflops. They're talking about how much work gets done per watt, per dollar, per second. In other words, how much real progress you get instead of wasted overhead. GPUs win by throwing power at the problem. This chip wins by not wasting it in the first place. For PC builders, a good way to think about this is specialization. A GPU is like a monster gaming PC, running every background process imaginable, just to do one job really well. This chip is more like a console built for a single title. No extra baggage, no unused features, no wasted silicon. It can't do everything, but what it does do, it does with terrifying efficiency. And that's the key point most people miss. This chip is not meant to replace your graphics card. It doesn't render games. It doesn't care about ray tracing. It exists solely to run AI workloads as efficiently as possible. That's why comparing it directly to a gaming GPU misses the point. The threat isn't that it outperforms GPUs in gaming, it's that it removes the need for GPUs in AI at all. Once AI no longer needs GPUs, the entire justification for ever larger, ever more expensive cards starts to fall apart. The demand pressure that pushed GPUs into absurd power and pricing territory begins to ease. And the company that benefited the most from AI's GPU dependency suddenly faces a future where that dependency no longer exists. And this is where the story gets uncomfortable for Nvidia, because this chip doesn't challenge Nvidia's performance numbers. It challenges the assumption that GPUs are even necessary. Why this breaks Nvidia's playbook. Nvidia's real advantage was never just faster GPUs, it was control. For years, Nvidia didn't just sell hardware, it sold an ecosystem. CUDA became the default language of AI. Entire software stacks were built around Nvidia's architecture. Once companies committed, switching away became expensive, painful, and risky. That lock-in is what allowed Nvidia to dominate not just gaming, but AI, data centers, and cloud infrastructure all at once. But that strategy only works if everyone agrees on one assumption, that GPUs are the best way to do AI. The moment that assumption breaks, the software moat starts to matter a lot less. If AI workloads move to a completely different architecture, CUDA becomes irrelevant overnight. You can't lock developers into a platform they no longer need. And that's what makes this shift dangerous. Nvidia isn't being beaten at its own game. The game is being abandoned. For PC builders, this matters more than it sounds like it should. AI demand is what justified extreme GPU designs, massive dies, enormous coolers, exploding power targets. Those choices weren't made for gamers. They were made because AI buyers would pay for them. If AI stops buying gaming-adjacent GPUs, Nvidia loses the incentive to keep pushing cards in that direction. And that could fundamentally reshape what future GPUs look like. Think about it. If data centers no longer need consumer GPU architectures, gamers stop competing with trillion-dollar AI budgets. That pressure disappears. Pricing strategies change, product segmentation changes. Suddenly, Nvidia has to care a lot more about what gamers actually want again, because gamers become the primary market instead of an afterthought. And here's the irony. Nvidia didn't miscalculate performance. It optimized too well for a world where GPUs were the only option. That success created a blind spot. When you dominate long enough, you stop expecting someone to question the foundation itself. But that's exactly what this new chip does. It doesn't outperform Nvidia within the same rules. It refuses to play by them. Before we go any further, if this breakdown is already changing how you think about GPUs, hit like and subscribe. It helps the channel, and it tells me you want more deep dives like this, especially ones that actually matter to PC builders. Because the real story isn't that Nvidia is losing today, it's that the future Nvidia optimized for might not be the future that shows up. And the reason this happened at all has less to do with technology and more to do with pressure. That's where things get really interesting. The sanctions that accidentally created a GPU killer. This chip didn't appear out of nowhere. It's the direct result of pressure. When access to advanced GPUs was cut off, the assumption was simple. Slow China down by denying them Nvidia hardware. No high-end GPUs, no cutting-edge AI. On paper, that logic made sense. GPUs had become so dominant that it felt like blocking them would block progress itself. But that strategy came with an unintended side effect. When you remove access to the default solution, you force people to ask a dangerous question. What if the default solution isn't actually the best one? Instead of trying to recreate Nvidia's GPUs node for node, which would have been nearly impossible under restrictions, Chinese researchers were pushed into rethinking the problem from scratch. Not, how do we build a GPU, but how do we run AI without one? That distinction changes everything. Without the option to rely on brute force GPU scaling, efficiency stopped being a bonus and became the mission. Every watt mattered. Every memory access mattered. Every unnecessary instruction became a liability. The result wasn't a slower workaround. It was a fundamentally different architecture, optimized for a world where power, supply chains, and access could not be taken for granted. This is a pattern we've seen before. Constraints don't just slow progress, they redirect it. When copying becomes impossible, innovation stops being incremental and starts being structural. Instead of chasing Nvidia's roadmap, this approach stepped off it entirely. And ironically, that's what allowed such dramatic efficiency gains to even be possible. The most uncomfortable part for Nvidia isn't that this chip exists, it's why it exists. It proves that GPUs weren't the inevitable endgame for AI. They were just the most convenient option when everyone had access to the same tools. Take those tools away, and suddenly new ideas. Have room to breathe. And here's the key takeaway for PC builders. This wasn't built to compete with your graphics card. It was built because GPUs were unavailable. But in solving that problem, it exposed how much of modern AI was being held together by brute force rather than smart design. And once someone proves there's another way to do it, one that's cheaper, cooler, and dramatically more efficient, the conversation shifts from, can we do this, to, why are we still doing it the old way? That's when the performance numbers start to matter, because next, we need to talk about the 1000x faster claim. What it actually means, what it doesn't, and why it isn't as crazy as it sounds. Is 1000x faster real? Let's translate the hype. Let's address the number everyone gets stuck on. 1000x faster. Taken literally, it sounds ridiculous. No chip is running 1,000 times more clock speed than a modern GPU, and no one serious is claiming that. What's actually being measured here isn't raw speed, it's efficiency. How much useful AI work gets done per watt, per dollar, and per unit of time. And once you frame it that way, the gap starts to make sense. Modern GPUs waste an enormous amount of effort moving data around. Data leaves memory, travels across buses, gets processed, then goes back to memory, over and over again. Each trip costs time and power. Multiply that by trillions of operations, and the overhead becomes massive. This new architecture strips most of that away. Data stays close to where computation happens. There's less waiting, less shuffling, and far fewer cycles burned on work that doesn't actually move the model forward. That's where the huge multiplier comes from. Not because the chip is magically faster, but because it's not doing unnecessary work in the first place. In very specific AI workloads, especially inference and tightly scoped training tasks, the efficiency difference can be staggering. Tasks that might take days on a GPU cluster can be compressed into hours when the bottlenecks disappear. Now, here's the important reality check. This does not replace gaming GPUs. It doesn't run games. It doesn't accelerate ray tracing. It doesn't care about frame time consistency or driver support. If you're thinking, should I wait for this instead of buying a GPU? The answer is no. That's not the point. The point is what happens around GPUs when AI no longer needs them. Once AI workloads migrate away from general-purpose GPUs, the artificial demand that's been inflating GPU prices starts to weaken. The justification for extreme power targets fades. The need to design cards around data center priorities disappears. And suddenly, GPU design can start drifting back toward efficiency, thermals, and real-world PC use, instead of raw compute density at any cost. So when people argue about whether 1000x faster is real, they're missing the bigger picture. Even if the real-world gain is 100x, or 50x, or 10x, that's still enough to break the dependency that made GPUs untouchable in AI. And once that dependency breaks, GPUs stop being the center of the AI universe. They become what they were always meant to be, one tool among many. And that's exactly why this still matters to you, even if you never run a single AI model on your PC, because the real impact shows up after the performance charts, when the market starts reacting. Why this still matters. If you only build gaming PCs, it's easy to look at all of this and think it doesn't apply to you. You're not training models, you're not running inference at scale. You just want high frame rates, reasonable power draw, and a GPU that doesn't cost as much as the rest of your system combined. But that's exactly why this shift matters more than you might expect. For years, PC builders have been paying AI prices for gaming hardware, even when you weren't competing directly with data centers. The entire GPU market was shaped around AI demand. That demand justified massive dies, extreme power targets, and pricing strategies that assumed someone, somewhere, would always pay more. Gamers were never the highest bidder. They were just along for the ride. And as long as AI needed GPUs, that imbalance wasn't going to change. If AI starts moving away from GPUs, that pressure eases. Nvidia no longer gets to treat gaming cards as a side product of data center silicon. The incentives change. Suddenly, efficiency matters again. Thermals matter again. price to performance matters again, not because Nvidia suddenly became generous, but because the market forces that pushed GPUs in the wrong direction lose their grip. This is also why future GPUs might stop getting bigger and start getting smarter, less brute force, more specialization, better power curves, designs that actually make sense in a consumer PC instead of a server rack. The same kind of thinking that made this AI chip so efficient is exactly the kind of thinking gamers have been begging for, even if it's arriving from an unexpected direction. There's another angle here too. Once AI stops dominating the narrative, competition has room to breathe. Alternative architectures, different approaches, new priorities. The GPU market becomes about users again instead of just workloads. That doesn't happen overnight, but this is how those shifts begin, quietly, structurally, and long before most people notice. So no, this isn't about your current GPU suddenly being obsolete. It's about the next few generations being shaped by a different set of rules that might finally favor the people actually buying and using these cards at home. And that brings us to the real verdict, because this story doesn't end with GPUs dying. It ends with GPUs being forced to evolve. The verdict: this doesn't kill GPUs. It changes their destiny. This isn't the end of GPUs, and it's definitely not the end of PC building. What's ending is the idea that one piece of hardware gets to dominate every workload forever. GPUs didn't fail. They succeeded so completely that the world stopped questioning whether they were still the right tool for everything. And that's exactly when disruption becomes inevitable. The chip coming out of China doesn't matter because it's faster in a benchmark. It matters because it proves AI doesn't need to bend itself around GPUs anymore. Once that realization spreads, Nvidia's grip on AI compute loosens, not overnight, but structurally. And when AI demand stops dictating GPU design, the entire market starts to rebalance. For PC builders, that's not bad news. It's overdue news. Less pressure from data centers means less justification for absurd power draw, oversized cards, and prices that feel disconnected from reality. It opens the door for GPUs that make sense again, not just on paper, but in real builds, real cases, and real power budgets. The next GPU revolution might not come from a bigger die or more watts. It might come from smarter design, better efficiency, and specialization that actually benefits users instead of infrastructure. And the irony is that the push for that future didn't come from gamers or enthusiasts. It came from AI outgrowing the hardware it once depended on. So, if you're a PC builder watching this, the takeaway is simple. Don't panic. Don't rush an upgrade, but pay attention. Because the rules that shaped GPUs for the last decade are starting to break, and what replaces them could finally be built with you in mind again. And when AI stops fighting you for GPUs, that's when things finally start to change. So no, this isn't the death of GPUs. It's the end of GPUs being forced to do everything. AI, moving away from graphics cards, doesn't hurt PC builders. It finally takes the pressure off. Less competition with data centers. Less excuse for insane power draw. Less reason for GPUs to keep getting bigger, hotter, and more expensive, just to satisfy workloads you never asked for. The next few years are going to be about efficiency, smarter design, and who actually gets prioritized again. If you build PCs, this is something you'll want to keep an eye on. If this video helped you understand where things are heading, hit like, subscribe, and let me know in the comments. Do you think AI leaving GPUs helps gamers, or do you think prices will still stay high? Either way, the old rules are breaking, and that's when things get interesting.